In the ongoing exploration of our universe, every journey begins with the eye. Only the eye can travel to the stars and beyond, far outpacing the meager reach of any human astronaut or probe. Chasing the ancient light of distant galaxies back to the dawn of cosmic history. In this epic journey of discovery, no eye been more revealing and more awe-inspiring than the Hubble Space Telescope.
Moving out. Copy, P3.
We're stalling minus 0.05 at 100.
The Hubble is not the largest telescope ever built, but it is the first large telescope ever to fly in space. This unique vantage point, high above the blurring effects of Earth's atmosphere, is the perfect perch for exploring everything from nearby planets to distant galaxies. Unlike telescopes on Earth, the Hubble can't be maintained and improved on a routine basis. Astronomers can't just drive to the Hubble to give it a tune-up. Instead, the telescope depended on visits from the Space Shuttle and its crew to make repairs and install new cameras. This is not an easy task, and missions to the Hubble have been among the most challenging and exciting in the history of human spaceflight. And then, on February 1st, 2003, disaster struck. The Space Shuttle Columbia was lost, taking the lives of 7 astronauts. Columbia's mission was not related to the Hubble, but its loss was to have a profound impact on the Space Telescope. After the accident, the remaining space shuttles were grounded, which postponed a 5th and final mission to bring new cameras and replacement parts to the Hubble. Two years later, even with new safety measures in place and the shuttles heading back into orbit, the Hubble repair mission was officially off the schedule. The reason was human safety. The Columbia disaster demonstrated how dangerous a space shuttle mission can be. Hubble's supporters were deeply disappointed. Without human support, it seemed Hubble's great eye on the universe would close forever. The telescope would slowly shut down and, in time, come crashing back to Earth. But scientists asked NASA to reconsider its decision. Flight engineers began working on scenarios that would involve one shuttle going to the telescope with another one ready on the launch pad in case of a problem. And by late 2006, with confidence in the shuttle program restored, NASA was ready to try to save the Hubble. The job would not be easy. During the years that the shuttle was grounded, the Hubble was showing signs of age. Its cameras were malfunctioning. Batteries and gyroscopes that were essential for powering and pointing the telescope were failing too. As engineers began to visualize the sequence of repairs that would be needed to restore the telescope to its full operations, it soon became clear that this would be the most ambitious mission to the Hubble ever attempted. A giant pool with a full-sized mock-up of the Hubble was used to simulate the weightlessness of space. Meanwhile, Hubble's new parts were brought out of the clean room and readied for launch. They included a pair of new cameras designed to transform the Space Telescope and image the universe as never before. The Wide Field Camera 3 is a versatile multi-wavelength detector capable of imaging distant objects across a broad spectrum of colors. Also on deck was the Cosmic Origins spectrograph, designed to use the light of distant sources as a way to probe the large-scale distribution of matter throughout the universe. Finally, on May 11th, 2009, the rescue mission was underway.
7, 6, 5, 4, 3, 2, 1, and liftoff of Space Shuttle Atlantis. Final visit to enhance the vision of Hubble into the deepest grandeur of our universe.
Bypass across the board, Scooter, no action.
Houston Atlantis for Star Tracker.
Scooter, go ahead for Star Tracker.
We see that star approaching from the east.
Hey, that's terrific news. I guess the last time we've seen Hubble up close was March of '02.
From Houston Atlantis, 200 feet.
No previous servicing mission had ever demanded so much of astronauts in such a short time.
Houston Atlantis. Hubble has arrived on board Atlantis with the arm.
By now, it was more than 7 years since someone had visited the telescope, and the Hubble was badly in need of attention.
John, coming out. Yeah, I'm just looking out the window here, and it's an unbelievably beautiful sight. Amazingly, the exterior of Hubble, an old man of 19 years in space, still looks in fantastic shape.
Installing the wide field camera was challenging but straightforward.
Counterclockwise, 2.
The new camera was built to fit neatly into the space left by its predecessor.
Look good? Looks good to me. I definitely got it. Excellent.
The Cosmic Origins spectrograph fit into another space, previously taken up by a device once used to correct the built-in flaw in Hubble's optics.
Coming in now.
Okay. And another inch down.
One more inch down.
This one feels different.
All of Hubble's new instruments now correct the optics automatically.
This one feels like it won't sit flush on the plate.
What kind of curves do you think Hubble will throw at you? I don't know. It's been Dave surprises each day.
You're making no more away, right only.
The most challenging fix of all was to Hubble's advanced camera for surveys. Since it was installed in 2002, the ACS had created some of Hubble's most spectacular images.
Takes a few more turns to get it
But
out
a
of the-
short circuit knocked out the camera after 5 productive years. Now astronauts would try to get it back.
Turn 1 is out. Nice. I heard that. Thank you, great, John. Nice job.
Nice job, Tom.
Incredibly, the repair went without a hitch. The ACS was back online, and with the replacement of batteries and gyroscopes as well as other repairs completed, the Space Telescope was ready to return to work. It was time to say goodbye to Hubble.
Flight controllers off.
Oh, baby, look at that.
What a beautiful spaceship we're on, guys. It's a real privilege to get to see what we're seeing and get to work on this magnificent machine. Hubble isn't just a satellite. It's about humanity's quest for knowledge. As Arthur C. Clarke says, the only way of finding the limits of the possible is by going beyond them into the impossible.
No one would ever see the Hubble this close again. What astronomers would see through the Hubble's new and improved cameras was yet to come. Like a dandelion adrift in a field of stars, a small, cloudy patch of light in the southern constellation Centaurus draws the eye. This is Omega Centauri. Located some 16,000 light-years from Earth, it is a vast congregation of stars known as a globular cluster. It formed more than 10 billion years ago and now moves through space like a cloud of fireflies as it orbits the center of our Milky Way galaxy. For astronomers, globular clusters are like laboratories, tailor-made for studying the evolution and dynamics of stars. That made Omega Centauri an ideal target for testing the new power of a restored Hubble Space Telescope. In this image, taken soon after Hubble's dramatic repair in May 2009, the telescope's new wide-field camera peers through millions of stars to reveal the cluster's sparkling heart. The stars' dazzling colors offer a clue to their history. As expected, most are yellow or red, indicating these stars are entering their old age after shining for billions of years. But the blue stars, which are much hotter, seem a mystery because blue stars should be very young. Astronomers now suspect some of these blue stars are the result of stellar collisions and mergers. The amazing clarity with which Hubble can view these stars also gives astronomers a window into the future. By comparing this image with earlier images of Omega Centauri, Hubble can see that the stars have moved. And by extrapolating those motions, astronomers can simulate a 10,000-year timeline, showing how the stars will migrate as each follows its own course. Since Hubble was first launched, one of its great achievements has been to reveal in stunning and colorful detail the complex cycle of life and death among stars. Now, with its new wide-field camera in place, Hubble is showing us this process as never before. Here we see in the death of a single star a celestial metamorphosis. Its energy spent, the star has blown off its outer layers, forming what looks like a cosmic butterfly. The details in this image reveal that stellar death is a multi-stage process, with gas ejected at different times and at different speeds to form a remarkably complex shape. The details are important because the material ejected by dying stars is ultimately what will be recycled into new stars and new solar systems, including some with planets capable of developing and supporting life. Elsewhere, in the Carina Nebula, Hubble spies the fiery formation of new suns inside a vast and churning cloud of interstellar gas and dust. 7,500 light-years away, this is one of the brightest and most spectacular star-forming regions in our neck of the Milky Way galaxy. As Hubble zooms in, a blazing tapestry of glowing gas gives way to a more detailed look at a single pillar of dust, 3 light-years long, nestled within the nebula. Powerful stellar winds are gradually eroding the pillar, which acts as a cocoon, protecting a cache of newly formed stars and planets within. With its infrared capability, Hubble's wide-field camera can peer inside the Carina Nebula and reveal hidden details. Here, the infrared view reveals high-speed jets of ionized gas, which point back to a newborn star within the cloud. The jets are a telltale sign of stellar birth, and they signal the arrival of a new solar system on the cosmic stage. Peering out at the Large Magellanic Cloud, a companion galaxy that orbits the Milky Way, Hubble can see the entire pageant of stellar birth and death in one image. This is the Tarantula Nebula, one of the most active star-forming regions found anywhere in space. Here, a cluster of freshly minted blue supergiant stars light up a vast complex of interstellar gas with their intense energy. Many of these stars are burning so ferociously, they will one day be gone as quickly as they came, exploding as supernovas bright enough to be seen on Earth without a telescope. In the process, they will cook the matter in their cores, spewing out the heaviest elements in nature like iron, nickel, gold, and silver, enriching the Large Magellanic Cloud with the same kinds of atoms that, in our galaxy, have been crucial to the development of civilization. With its improved powers of perception, the Hubble has again become the best way for astronomers to trace the ebb and flow of atoms in our own galaxy. But what Hubble is ideally built to do is tell us a story on a grander scale, the birth of the galaxies. That's why, once Hubble's vision was restored, astronomers were keen to point the telescope out to the farthest reaches of space. Before the Hubble, the youthful days of our universe were off limits to astronomers. Of course, it's possible to look back in time simply by peering far off into space. Because the light from distant galaxies needs time to reach us, we can see those objects not as they are today, but as they once were long ago. The trouble is, even looking at galaxies that are millions of light years away isn't enough to see what the universe was like at an earlier stage, when astronomers think most galaxies formed. To do that, a telescope needs to look back about 10 billion light years, and Hubble has been doing just that. Some of the best views of this elusive period come from the Hubble Ultra Deep Field, a sampling of the universe at the very limit of Hubble's perception. To achieve the Ultra Deep Field, Hubble literally spent days staring into empty space. As the extremely faint light of distant galaxies began to build up on Hubble's sensitive detectors, an astonishing picture of the early universe began to emerge. What Hubble found is that at these great distances, galaxies tend to be smaller and more distorted in shape. This tantalizing result means that Hubble is beginning to see back to an era when the galaxies were still forming, mere adolescents on their way to becoming the grand star systems we see today. Since its repair, Hubble has returned to the ultra-deep field and again gone diving into this cosmic well, this time using the infrared capability of the Wide Field Camera 3. The effort has yielded Hubble's most distant finds to date, a handful of tiny galaxies that appear to be a staggering 13 billion light-years away. This not only breaks a record, it tells astronomers that the earliest galaxies must have formed quickly, already springing into existence before the universe was 5% its current age. With this incredible feat, the reborn Hubble Space Telescope has now put us on the threshold of the birth of galaxies, one of the great milestones of cosmic history. To actually see the galaxies being born, astronomers know they'll have to go one step further, and another space telescope will have to get them there. Currently, the James Webb Space Telescope, Hubble's direct successor, is scheduled for launch in 2018. By then, Hubble will have finished its long and incredibly successful mission. Rarely has one instrument done so much to change our understanding of the universe. With its newly restored and improved eye on the cosmos, Hubble is not only becoming a legend in its own time, it's setting the course for the next era of cosmic discovery.